Okay, so putting what we were doing in the last video, I want to summarize the guidelines for solving a polynomial and rational inequality. Okay, now this might be a little bit different. Maybe it won't be exactly the steps they give in the book, but these are the ones that will. I just made things a little more precise. So essentially, it's the same. First thing is, given an inequality, you want to put all the non-zero terms on one side. So you have an inequality like one of these four things. Okay, where either some expression is either greater than or equal to 0, or less greater than 0, or less than or equal to 0, or less than 0. It doesn't matter which one of these you use. You can use any of them. You're just going to make a sign chart for p of x. So once you do that, you'll be able to read off the solution. The important thing is you have 0 on one side. Next, this expression p of x, if it's a polynomial, you want to factor it. If it's a rational function, you factor the numerator and denominator. And then that's important because the factors are going to determine where this expression changes, where p of x changes sign. So they'll change sign. If they change sign, it will be where the factors are 0. So you want to set each factor equal to 0 and solve. Okay, and then you're going to make a sign chart for each factor, which is what we did before. These are going to be factors like x minus 3, 5 minus x, x minus 1 raised to the second power, something like that. So making a sign chart for each factor won't be too bad. It'll change at most once. And then you can put these sign charts on top of each other and make a sign chart for p of x. Now, there is one way you can skip this middle step if you want to just make a chart, a single chart with you just using the numbers where the factors are 0. That's okay too. And then you can just plug in a number on each interval. So you'll make a sign chart for p of x, and then once you do that, you can basically use that to read off the solution. And up here, like if your inequality is in one of these forms, then you want to look for the intervals where p of x is positive. And if it's one of these two forms, you look where it's negative. The important thing to do is to check the endpoints, because the intervals the sign chart won't tell you what happens at the endpoints. And the good news is it's not going to be, you only have like a few, 1 or 2 or 3 numbers to check. You can plug that in. And usually what will happen if you plug it into p of x, you'll either get 0 or you'll get something that's undefined. Okay, so obviously if it's undefined, it can't be a solution. Okay, if you plug it in and it's equal to 0, it may or may not be a solution. If it's one of these two, then you keep the solution. If it's one of these two, then you don't. So check endpoints, and then remember the overall theme. This might be a little silly to think, but remember, sign charts are going to be friends, or at least your friends in this particular section. So let's look at maybe one example in this video. Here we have a rational function that's greater than or equal to 0. So the first step is already done. Okay. The second step is already done. The numerator and denominator are clearly factored. Okay. Then the next thing, well, where is each factor equal to 0? We could say set x plus 1 equal to 0, and you get x equals negative 1. Set x minus 3 equals 0, you get x equals 3. Okay. All right. So these are going to be the places where this changes sign, if it changes sign at all. Next, we can make a sign chart for x plus 1 and a sign chart for x minus 3. And one thing you want to do is, because we know we don't want to make these things, we're making these on top of each other. So obviously we want negative 1 to come before 3. Okay. And then we'll see that x plus 1, that goes from negative to positive. and x minus 3 goes from negative to positive. Okay. And then we can make a final sign chart. We bring these two numbers down now. And we see here on the first interval we have a negative divide by a negative, so that's going to be positive. Here we have a positive divided by a negative. Here we have a positive divided by a positive. Okay. Now, which interval do we want? Well, this says we want this expression to be greater than or equal to 0. So we want the positive intervals. And then finally, when we check our endpoints, which ones do we want? Well, if we plug in -1 here, we get 0. And 0 is greater than or equal to 0. So we include -1. If we plug next, we'll have about 3. If we plug in 3 here, we get 4 over 0. So that's going to be undefined. So that can't be a solution. So we include -1, we do not include 3. So in the interval notation, our solution will be -infinity to -1 with a square bracket, union 3 to infinity, with a round bracket here because we're not including 3.